The problem goes like this. First of all, there is this right triangle with a side of 15 centimeter and 20 centimeter on this side. Now it says that there is a double cone formed by revolving from the hypotenuse. It goes like this. As you can see, there is a double cone formed, okay? Because the triangle is basically rotates around the hypotenuse. You can imagine something like that. So this is basically the same triangle. So the question is, what is the surface area and the volume of the double cone? Now let's find the surface area first. Let's say that this is A, B, C, and D. From B, let's draw a line that perpendicular to AC. Let's say that the intersection is K. Now do the same from D. Now you will realize that it forms a 180-degree angle, which means B, K, and D is in a single line. Now let's look at the first smaller cones, which is the ABD one. As you can see, BK equals BD. BK is the radius of the circle base. What does it mean is that we have to find BK first before do anything further, because the formula of finding the net of a cone is P times BK times AB, or P times R times A. But here the BK is the R and AB is the A. So we still don't know the BK. We have to find it first. So how to find it? Okay, let's erase all of this and see it from a simpler perspective, which is from the two-dimensional perspective. Let's see from A, B, C. Wait. Okay, from Pythagoras, AC squared equals AB squared plus BC squared, which is clearly AC equals 25 centimeter. Now we are going to use a concept called similarity. Now we see that the angle ACB, let's say that it is alpha. Okay, this is alpha. Now what is the angle KBC? It is 90 degree minus alpha, because this is 90 degree, this is 90 degree, okay? So does it mean 90 plus alpha plus something here equals 180? So KBC is 90 minus alpha. What does it mean? It means the angle KBA equals alpha, because KBA is basically a 90 degree angle minus KBC. Now we got this equals alpha, and this is 90 minus alpha. Now let's arrange both the triangle AKB and ABC. Now this is the bigger one, which is ABC. As you can see here, both of the triangle is similar, because all the angles are the same. Why we know that the angles are the same? Because two of them is the same. It means the third one is going to be the same too. Why? Because all the three sum is equal to 180 degree, so they will be equals. Now you know that they are similar. Now how we find bk from this? Well, it is rather easy. We can make a ratio like this: bk over 15. Wait, let me make it simple. bk over ba equals cb over ca. This over this equals this over this in ratio because they are similar. So we can make it like this: bk over 15 equals 20 over 25 or 4 over 5. Hence we get bk equals 12 centimeter. Let's get back to the original smaller cone IBD. Okay, I just realized that I cannot erase the figure here. I don't know why, but it's fine. I'm just gonna use the lower one. So A, B, D, and K is here. That says that this is 12. We have found it, and this is 15. Now, what is the surface area of both of these double cones? First of all, the surface area of a cone is the base plus the net. But here, the base doesn't count. Base doesn't count. Only net. Why? Because, well, you see, it in 3D it's gonna look like this. You won't see the circle in real life. There is no surface area for the circle, only the net. So how do we find the surface area for the net here? Let's just use the quick formula, which is P times A times R, which A is the slope AB like this, or AD, it's the same, and R is the radius of the base circle. Now we got A is 15 and R is BK, which is 12. Now we can simply get P times 5 times 15 times 12. Which is 180 P centimeter square. Now after this is we going to find the surface area of the bottom part. Let me place it here. So what is the surface area of the bottom part? It's the same, but we just change this into 20 centimeter. So it's P times 20 times 12. What is that? It's 240 P centimeter squares. Now what is the surface area of both of them? We simply get the sum of both of them, which is 240 P times this. We added 180 P centimeter square, which we got 420 P centimeter squares. So here is the surface area of these double cones. Okay, now let's find the volume. The formula of finding the volume of a cone is the area of the base circle times the height times a third, which means for the smaller ABD cone it goes like this: P times 12 square, which is area of the base circle, and then times the height AK times AK times a third of all of them. Okay, now this is going to be add to the bottom part, which is the BC cone. This time it is 20 centimeter, but it doesn't matter because we only care about the height CK. Now the area for this one is P times 12 centimeters times CK times a third. If you realize, it can be simplified to a third times P times 12 squares times AK plus CK, which we can simplify it again into P times 48 times AK, because AK plus CK is is AC. Okay, as you can see here, AK Wait. AK plus CK is simply AC. Now let's get back here. P times 48 times 25. We have find AC in the previous calculation. Now P times 48 times 25 is P times 4 times 12 times 25. P times 20 times 100 or 1200 P centimeter cube. So that's the volume of these double cones. Okay, let's put the surface area here too. Here's the answer of the problem here. As you can see, it's very hard to explain this in a minute, so I think it's the real challenge, because explaining even a simple problem like this is very hard in a minute, because you have to cramp those information in really tight space. It's almost impossible. I think most of people won't understand the 1 minute explanation by me, because it's just so fast. I think if I also see it from my friends explanation in a 1 minute, I also too won't understand. But I think if I explain it a little bit slowly like this, it is going to be a lot more understandable. I hope you I hope this is going to explain everything. Well, that's it for this problem. Thank you.